Welcome to the Math Record. Today we'll be covering the CCML Geometry Contest 2 2016-2017 Division A. Okay, question 1. Line L and M are parallel, and this is the intersection line. So the x squared minus 3 angle right here is the same thing as this angle on top of 11x plus 3. So x squared minus 3 plus 11x plus 3 has to be equal 180 degrees. So the negative 3 and the 3 cross out, and you plus 11x equals 180. So minus 180 to the other side, right? It equals 0. Now you have basically factor this out. So you get x plus 20 and x minus 9. X cannot be negative because if you put a negative in 11x plus 3, it's going to turn negative. You can have a negative angle. So x is equal to 9. So the answer is 9. Okay, question 2. How many square 6-inch tiles are needed to cover a floor with dimensions of 6.5 yards by 5.5 feet? So 12 inches equals 1 feet, and 3 feet equals 1 yard. Okay, so basically they're saying 36 inches equals 1 yard. So we need to convert this yards into inches. So that's 36. So 3.5 is 7/2 times 36, divide by 2, that's 18. 18 times 7 is 126. Okay, so we have 126. So we have 126 inch by, and now we need to convert the feet into inches, and it's just 12 inches per feet. So that's 31/2 times 12. So divide by 2 is 6. So you get 186 inch. Okay. So our next number is 186. So the area of the floor would just be 126 times 186 divided by the amount of tiles, the area of tiles to get the amount of tiles. So it'd just be 6 times 6. So 126 divided by 6 is the same as 21. Divide 21 by 3 to get 7, and 6 divided by 3 is 2, and 186 divided by 2 is 93. So we have 93 and 7 left. So 93 times 7, that's 21, 63, 65. So the answer is 651. That's your answer. Okay, question 3. The points 2, 1, 3k, and 5, 2 are collinear. Find the value of k. If they're collinear, they're on the same line, right? So you have 3 points are on the same line. Basically, it tells us that since they're on the same line, it must be on the same slope. They must have the same slope. So let's just use 5, 2, and 3k. So that's 2 minus k all over change of y or change of x. So 5 minus 3 is 2. Sorry, 2 is equal to now we have 2, 1, and 3k, so k minus 1. And 3 minus 2 is 1. So cross multiply, you get 2k minus 2 is equal to 2 minus k. So add k to the other side, you get ek. Add 2 to the other side, you get 4. So k is equal to 4/3. That's your answer. Okay. Basically, that's simple. That's for so the answer is 4/3 for question 3. Now, for items 4 and 5, use the diagram below. Okay. Question 4. Find the angle of DBC. Okay, let's draw this picture out first. So, right? And we have a line, this, and we have 113. And it says DE and AC is parallel. Okay, so it's parallel. So any single kind of lines make like intersections that are kind of the same-ish. And then AB, this line is parallel to BC. So they're telling me that this is a right angle, even though my picture is not good. It's a 90 degrees. And CE bisects ACB. So these two are the same angles. So this angle is the same as this angle. Okay. So far, that's what we know. So we know 113 plus this angle is 180. So this angle is 67 degrees, right? And we know since this is a triangle, right? ABC right here is a triangle. That means the 90 degrees plus the 67 degrees plus this has to be 180. So this is 20. Wait, it's 23 degrees. This together is 20 degrees. But since CE bisects angle ABC ACB, that means each of the 23 degrees is halved. So this is 11.5, and this is also 11.5. So that makes 23 plus the 67, which is 90, plus that 90 is 180. So based on that, we know this is 67 and this is 11.5, so that makes 68.5. And we need to get plus this angle right here has to be 180 degrees, so we have 180 minus 68.5. So let's say that's 69, right? So that's 6, 7. So that's 111. So 111.5, right? 111.5. And we need to erase this. Okay. And since these are vertical angles, CE and AB, we could say this is also 111.5. And since this angle is the same as thing as this angle, just add, and these two angles, x plus 111.5 has equal to 180. You basically just write the other angle, which is just 67 plus 11.5, which is 78.5. Sorry, wait. 70. Oops, sorry, it's 101.5. Okay, and this is 78.5. Okay, and yep, so that's true. So that makes 100 and 179 and 180. Okay, so that's perfect. So this is 78.5 also. So based on that, since line ED and AC or FC is parallel, that means the 150 degree 100 and 11.5 degrees is the same thing over here. So this is also 11.5. This is 11.5 and this is 101.5. It's kind of the same thing as here, so this one has to be 67. We don't have to do the calculations again. So 67 and this one is 90 degrees, so this one has to be 20 degrees. So angle DBC for question 4 is just 23 degrees. Okay, we have 24 degrees. And let's use that for use this diagram for question 5. So what's the angle of ACG? ACG is just right here. So it's 101.5. Okay. Basically, just a bunch of properties that tell you how to do this. How to like get the angles. So for question 4 and 5. Just know your properties and you should be fine. Question 6. Find the area of a circle with diameter endpoints -1, 5 and 5, 7. Okay, so in this type of question, you just need to find the midpoint and you need to find the radius. So you want to find the radius, just find the distance between these two points and then like half of it. So -1 and 5, that's 6. The between them is 6. And then the distance between 5 and 7 is 2. So that is the same thing as the distance between the x is 6 and the distance between the y is 2. So getting in the hypotenuse is the distance is 6 squared plus 2 squared, basically square rooted. And that would be square root 38, 36, and that's 4, so that's square root 40. Right, so the distance is square root 40. To get the radius, it's just square root 40 divided by 2, so that's the radius. Okay, so actually we don't need to find the midpoint. Find the area of circle, it's just pi radius squared. So it's pi times this radius. So square root 40 squared is just 40, and 2 squared is just 4. So this simplifies to 10 pi. So the area of 6 is 10 pi. Sorry if it doesn't look like a pie. I kind of just draw like a 3/4 of a box. But you know, that's preference. Number 7, find angles B, E, A. So this angle. BE. Let's actually kind of draw this diagram out. Draw a line here and draw a line here. So this is 48 degrees and 35 column thing. I think it's seconds. And then BE, actually minutes probably. And then BE is the same thing as CE. So that means actually just remember that this is 48.35, right? I'm just gonna label it as X. Right? So they say BE is the same thing as CE, so this is X also. And AB is perpendicular to BC, so this is 90 minus X. And DE is parallel to BC, so this is also 90 minus X. Right? So this is similar to this triangle, and this is isosceles triangle. So we need to find angles B, E, A. So we need to find this angle right here. So this angle right here would just be 2 times this angle, which is X, 2 times X. Because think about it, if this is just this triangle right here, right, this 180 minus X, minus 2X, right? Because 180 minus 2X plus X is just 180. So, and this is a line, right? So this thing would technically just be this angle plus 180 minus 2x has to be equal to 180. So this angle together also equals 2x, right? So angle BEA is equal to 2x. So we just need to multiply 48 degrees and 35 minutes, or I think seconds or minutes, and then you just multiply by 2. So we have 96 degrees, and 35 times 2 is 70. 60 of this equals 1 more degree, so just add 1 here to make 97 degrees, and then minus 60 is 10. Sorry. I don't know why I put a degrees in here. So the answer is for number 7 is 97 degrees and 10 minutes or seconds. I'm not exactly sure what the the notation is, but just write it. So 97 degrees and 10 like comma. And then 8. Give the sum of x given that the sum of x and y, sorry. Okay. Given that the sum of x and y is 68, find x. So this kind of diagram, okay, let's just draw it out. I'm just gonna move it a little bit over and right here. It doesn't really change anything. So this is 75, and this is 50. And over here is x, and over here is y. Okay. So what you're gonna do is that you see this line, you're gonna extend this out, but still gonna like be still straight. Okay. So since this is 75, right? Then this line is a straight line, right? So this has to be add up to 180. So this is, let's say this z plus 75 has to be 180. So z has to be 105, right? And we have basically y right here, and then y has to be since this is parallel, right? Where see it, right? It says that lines S and T is parallel. So this line and this line is parallel. So if this is y, then this is also y. And this right here is 180 minus x, right? Because this is also a line, straight line. So 180 minus x plus x is 180. So since this is a quadrilateral, it has to add up to 360 degrees. So basically, it tells us that 105 plus 50 plus 180, that's 155 plus 180. Okay. Plus y minus x has to equal 360 degrees. And now that's 335 plus x plus y minus x is equal to 360. So x minus y is equal to 25 degrees, basically. So x minus y is 25. I mean, y minus x is 25. So we have y minus x is equal to 25. And we have number 8 at the first sentence given us is that the sum of x plus y, actually let's put y plus x, is easier to think about. Y plus x is equal to 68, right? So you add them together, you get 20y, 2y, and that gets 80, that's 93. So y is equal to 93 over 2. Okay, so you need to find x, right? So plug that back in and subtract it from 68. 68 times 2 is 136 over 2 minus 93 over 2. That gets you 43 over 2, which is x. So 8 is, so x, which is going to be in degrees, is 43 over 2 degrees. Or you could just write it as like mixed fraction, which would be 21 and a half. Okay. Number 9. In the figures below, A, B, A, B, C, A, D, F, and C, E, F are equilateral triangles, okay? If AD, actually let's draw this picture out first. So we gotta draw an equilateral triangle, another equilateral triangle, and another one. So they say AD to FE is, so AD to FE is 3 to 2. So this is 3 and this is 2. And find the ratio of the area of quadrilateral D, B, E, F, so the area of this thing, to the area of ABC of the entire basically triangle. So if this if 3x to 2x, that means all the side length has to be in that ratio. So actually, let's just write this as 3x, and this is 2x, so it's in some kind of ratio. That means this is also 3x to 2x, right? Then this is 2x, 3. Well, you could just write, they're not going to be the same thing, so let's say 3y all over 2y, and this will be 2z, and this will also be 3z. So based on this side length, alright, that means the entire triangle is 5, like, 5 times this variable. And this is 2 times of this variable, and this is 3 times of that variable. So, we got that information down. So based on that, since this is a 3 to 2, right, and this entire thing is 5, that means, area, let's just say it's, you know, like, kind of, like, out of 1. So technically, if this entire triangle is an area of 1, right? Then let's say ABC is area 1. Then technically, since this is 3, right? This is 3 and this is 2. Since this is 3 out of 5, that means the area is the square of that. So 3 out of 5 squared is 9 over 25. So the area of this is 9 over 25. Okay? And the area of this is 2 out of 5. Right? Square that, you get 4 out of 25. So this is 4 out of 25. So 9 plus 4 is 13 out of 25. This has to be 25 out of 25, so this thing has to be 12 out of 25. Right? So if this, so the ratio is basically 12 out of 25, which is this quadrilateral. So 12 out of 25 over the area, which we set was 1, so it's just 12 over 25 is the answer. Okay? You just need to understand similar triangles. So if the side length between similar triangles is, the general idea is that, let's say you had 2 similar triangles, right? And this side length is 4, and this side length is 5, then this let's say this area is x, right? Then this area would just be 4 over 5. Sorry, 4 over 5 squared x times x. So it's gotta be a squared of the ratio between their side lengths. That's the general idea, and you just use that to solve on number 9. Okay. Number 10. Two parallel lines have the equations. ax plus 3y is equal to 10 and 6x plus ay is equal to 7. Find all possible values for a. So if it has to have two parallel lines, the slope has to be the same. So move a to the other side. So this would be y is equal to negative a over 3x plus 10 over 3, right? And this would be y is equal to negative 6 over a x plus 7 over a. So basically, So based on this, negative 6a is equal to a over 3, negative a over 3. So negative 6a is equal to negative a over 3. So having that together, that gets x kind of cross multiply, so you get x squared is equal to 18. So a is equal to plus or minus square 13. This is just 3 times 3 times 2. So this would be plus or minus 3 square root 2. So can it be a plus square root 3 over 2? So if that's 3 square root of 2, right? Because we want to check if it's possible. So that's 3 square root 2. You got to multiply by square root 2 that side. So that's 3 square root 2. And that works. Yes, that's parallel. Now, if it's negative 3 square root 2, right? You got to multiply by negative square root 2. So that gets negative 3 square root 2, which is also parallel. So yes, it's plus or minus. So number 10 is plus or minus 3 square root 2. Number 11, find x. Okay, so this is 60 degrees, this is a line, and this makes this line here. And they say x minus y and x plus y. So let's kind of draw this out again. 60 degrees, x minus y, and x plus y. The general rule for like these angles would be like the general. I'll just make another diagram, something like this. So you have angle A, right, and this angle B. Then this angle right here is A plus B. This angle, A plus B. That's a general idea because it makes sense, right? Because the third angle would be 180 minus A minus B, because 180 minus B plus A plus B is just 180 degrees, which is a triangle. So then to get the other side, which is also a line, it's 180 degrees. It will be 180 minus A minus B. So you just need to cancel out the A and B. So you just add A and B, which is the same thing as the sum of these two angles, right? So that's the general idea which we're going to be using right now. So basically, 60 plus this angle has to equal x minus y. So this angle has to be equal to negative 60, because you want to cancel out that 60, plus x minus y. So that's the angle. And I don't know why I read it all the way up here. All the way down there, x plus y. And x plus y right here, and this angle plus negative 60 plus x minus y has to equal 180 degrees. So negative 60, there's two x's, so add 2x, and the y's cancel out to equal 180 degrees. So negative 60 to the other side, 2x is 240. So x has to be equal to 120 degrees. Basically, that's simple. X is 120. So number 11 is 120. I won't say degrees, 120, not degrees, it's just 120. Maybe 120 degrees. Okay. Number 12, a triangle is subdivided into tiers of smaller triangles, okay? So this triangle is made into smaller triangles. The bigger low shows 4 tiers, so 1, 2, 3, 4. If Tn is the number of triangles in a figure with n tiers, find T6 minus T4, the total amount of triangles in a thing with tiers. Okay. So we just basically need to count the triangles, which is kind of annoying. So what you do is that let's just make the 4 already. Actually, let's make a bigger diagram. Okay, so 1, 2, and 3. And we have here, which is another one. Oops. Sorry if the picture's bad. I very bad at drawing. Okay. So how many triangles are in here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if we're gonna count this big triangle, it's just gonna be 1, right? So you have 1 here, and the smaller triangles are 16, so that's 16. Now, if we're making triangles with 4, so this is 1 triangle, plus 2, plus 3, plus 4, plus 5, plus 6. So you're using 4 triangles to make 1 triangle, you have 6 more. Now, if you're using 3 triangles, right, that's 1, that's 2, and that's 3. So you have 1 plus 2 plus 3, right? So you have 3 more. So the total amount of now we need to think about, since you're making a triangle this way, now we need to think about making a triangle upside down, right? So you can make a triangle like this, right here, which is kind of weird, because before you were counting triangles like this, but now you're counting triangles like upside down. So we can't make a 1 by 1 triangle upside down, because technically it's already counted. So we just need to let's find a 2 by 2, which is right here. So you have 1 2 by 2. And you can't make any 3 by 3s because that's the only one. So 1 plus the other ones. So you have 1 plus 16 plus 6 plus 1 plus 3. So that's 9. That makes 9. That's 10. That's 26 and 27. So T4 is 27. Okay? So remember that T4 is 27. So T4 is 27. Now let's just draw a few more. Right? Well, let's move this. Try to get some room. Okay. So we need a T6. So just make this one here. Draw 2 more. X, X, X. Then put a line. Put a line. Put a line. Draw a line here. Draw a line here. And there's one more line right here. And one more line right here. Did I get everything? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So I basically have all the lines. So now we just need to count this again. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, which is 36. Sorry if this looks like an extra triangle. I just can't draw very well. So let me like redraw this actually. Kind of like this, and like here. Then make one right here, then right here. Right, so this one's 36. So it's 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So you have 36 individual ones. Now we're working by 2 by 2s. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 more plus 15. Now working with 3 by 3s, we have 1, 2, 3, 4, 5, 6, and 7, 8, 9, and 10. So we have 10 more. Now working with 5 by 5s, we have 1, and we have 2 and 3. So we have 3. And a 6 by 6, which is the entire thing, is just 1. Now we need to think about upside down. So upside down, we can't do 1x1s, right? So we now could do upside down 2x2s. So we have one right here. That's 1, and we have another one right here. That's 2, and that's 3, and that's 4. That's 5, and that's 6. So we have 6 2x2s upside down. Can we make a 3x3 upside down? Which we can make right here, which is 1. We can make 1 here, and that's all. So we have 36 plus 15 plus 10 plus 3 plus 1 plus 6 plus 1. So that makes 9, that's 10, that's 20, and that's 35. So that makes 60, 70, 71, 72. So you get 72 right here as the total amount of figures in n tiers. Um, and now we just need to find a T6 minus T4, which is equal to 45. Okay, I'm either missing some triangles or I don't know how to count. So 36 plus 15 plus 10 plus 3 plus 1 plus 6 plus 1 is equal to 72, right? Is that correct? Because that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Yeah, 36. This is 1, 2, 3, 4, 5, 6, and then 7, 8, 9, 10, and that's 15. Yep. 3 by 3s, 1, 2, 3, and then 4, 5, 6, 7, 8, 9, 10. Yeah, 10. And then 4 by 4s, we have 1, 2, 3. Wait, 1, 2, 3. Oh, I forgot. 4, 5, and 6. No, this is not 3. This is 6. And 5 by 5s. 1, 2, 3. Yep, the 5 by 5s are 3. And so this is the 1s. These are the 2s. These are 3s. These are 4s. That's 5s, and we need 1, 2, 3, 4, 5s. And the 6 is 1, and upside down is 1, 2. So sorry, I forgot some numbers. So it's not 72. It's 36 plus 15 plus 10 plus 6 plus 3 plus 6 plus 1 plus 1, right? So 36, that makes 9, that makes 10, so that's 20, that's 35, that's 71, that's 72, and that's 78. So our amount in T6 is 78. So 78 minus 27 is 51. Okay, this is kind of tedious and it takes a little bit of work. But it's also kind of tricky because you have to count upside down triangles that you might forget. So you need to count like 1 by 1s, 2 by 2s, 3 by 3s, 4 by 4, 5 by 5, 6 by 6, etc. If you have the amount. So if you have like a 7 tiers, then you have to count up from 1 by 1, 2 by 2, 3 by 3, 4 by 4, 5 by 5, 6 by 6, 7 by 7, basically. So it takes a lot of work, and then you have to do the reverse. So you have to do the upside down 2s, the upside down 3s, upside down 4s, just in case there are some, and then you have to stop and count all of them. You have to do it twice for T6 and T4. So question 12 is kind of tricky and tedious. But the answer for 12 is 51, as I shown in previous. A letter H is constructed in a square with a uniform width that is constructed in a square with uniform width that is a third of the square's side. Okay, if the square's area is 24, find the ratio of the letter's areas to its perimeter. So, and let's draw H. So they said that they said the square's area is 24, right? So an area is just side length squared. So so this would just be 2 square root 6. That length right here. So it's constructed in a square with a uniform width that is 1/3 of the square's side length. So this is a third, basically. So this would be constructed in a square with uniform width. So this is a third. That would be 2 square root 6/3, which is the same thing for this and this. And also for the bottom here, here, and here. And this thing is also 2 square root 6, basically. So this is also 1/3, I'm guessing, because this is 1/3, and this is 1/3, and this is 1/3. So 2 square root 6/3 times 2 square root 6/3 is just 4 times 6/9. Since there's two of them right here and right here, basically, as the area, then you have to multiply this by 2. Okay? So that would be divide by 3, that's a 2, and this is a 3. So this is 16/3. So the area of these two squares is 16/3, and the area of the entire thing is 24. So 24 minus 16/3. Let's access this out. We don't need this. We have 24 minus 16/3. Right. That is 72/3, which sorry. Minus 16/3 would get 56/3 as our area of the H. And the perimeter of the H is basically just, since we said the side length was 2 squared 6, right? Then basically you have side length here, which is 2 squared 6, this is 2 squared 6, and then this kind of adds up to 2 squared 6, and this kind of adds up to 2 squared 6. And this is a third of the side length, this is a third, this is a third, and this is a third. So basically we have 1, 2 squared 6, 2 squared 6, 3 squared 6, 4 squared 6, and a 5 squared 6. So we have 5 and 1/2 of square root 6. So we have 5 1/2, which is in improper, is 16/3 times 2 squared 6, which is equal to 32 squared 6/3. So that is its perimeter. So the ratio of the area, which is 56/3 divided by 32 squared 6/3 is the same thing as saying multiply by 3/32 square root 6. So the 3's kind of cancels out. Let's move this up. We need a little bit more room. And let's delete this because we don't need this. Okay. Sorry that's a little messy. Divide by 4 here to get 1 and 14. Divide by 4 here to get 8. Divide by 2 here to get 7. Divide by 2 here to get 4. Okay, and then multiply 6 to the top. Square root 6 to the top, so 7 square root 6. That's all we have left is 7. Multiplied by square root 6 on the top. So the square root 6 on the bottom just be 6. So 6 times 4 is 24. So your answer is 7 square root 6/24. So basically just like that. Pretty simple. Question 14. If points A 2, -3, and B 2, 6 with M, the midpoint of AB, the line with 3x plus 4y is equal to 4 intersect AB at point P. If point AB is selected at random, what's the probability of MP? What's the probability that line is on MP? So, given that AB and M is the midpoint, so just add them. The midpoint of 2 and 2, add them together and divide by 2. So 2 plus 2 is 4, divide by 2 is 2. And then 6 plus -3 is 3, divide by 2 is 3/2. So the midpoint of these 2 points, which is just like 2, -3, and 2, 6 right here. Oh, sorry. 2, -3, and 2, 6 right here would just be 2 and halfway between that, which is basically just 2 and 3/2, which is just like 1.5. So it's 4.5 from away from each one. Okay. That's M. the line 3x plus 4y is equal to 24 intersect AB at point P. So AB, the slope is 6 minus negative 3, which is 9. So 2 minus 2 is 4. Actually, this line is just, since it's at 2, negative 3, and 2, 6, the equation is just x is equal to 2. So if x is equal to 2, and we put that into the equation, then point P, which is be at 2, that's 6. 24 minus 6 is 18, and 18 divided by 4 is 9 over 2. So that's equal to point P. If a point on AB is selected at random, what is the probability that it will lie on MP? So basically how it looks is that we have a point from here. See, this is 3, this is negative 3, and this is at 2, 6, so this is positive 6. And this is at 1.5, so somewhere here. And this one is at 4.5, so somewhere around here. So this is 1.5, and this is 4.5. Right? So the distance between them is 3, and the entire distance of this line is 9, because the 6 and the 3 is 9. So choosing a point out of the 9, was it in that 3? So the answer is 1/3. So number 14 is 1/3. Question 15. How many different ways are possible from A to B if each path consists of moves to the right, up, and a single move left? So a single move left without retracing. Okay, let's draw this out. Let's draw this. And then you have 3 lines. 1, 2, and 3. Okay, the only place that you can actually go left on is these, right? Because if you go left on one of the first line or the second or the last line, if you go through like here, then you go here, you have to go back this way. And then you're retracing. So on this line, you're gonna have to retrace, so you can't do that. The same concept applies to here. So you go up here, that means you have to retrace back here. So it's impossible. So let's say you want to retrace here, then you have to go back here, which you're gonna retrace, which is impossible because when you go back left, what you do is that you have to go up. So that's the point. So if you go back like let's like draw like a simple path. So let's say you go here and you go here, you chase back, you have to go up, right? Because let's say you go this way, and then you go right here, and then you go back. You can't go back this way, and you can't go here. You can't go another left because you only go one single left. You have to go up. That's why the middle row is the only row where you can actually work with. So there's only 8 possible ways. There's 1 right here. There's 2, 3, 4, and 5, 6, 7, 8. Right? Those are the only possible ones where at the point, and then you could go back to another point. Those are the only possible points. So let's go through every single 8 points, which is kind of tedious. So there's one ways to go in each of these other points on the side right here. So one way, one way, one way, one way, because it's only A to here, or A here, here, here. It's a little harder version than the ones that are usually used without going a little left. So it's either right or up. Now it's right up and a single move to the left. So now let's say we're gonna work with this point. So there's only one way which you could go to get there. If you go up and then you move, you have to retrace. So you have to go through this line, basically. So you go through this line, there's only one way to go there. So this way has one way. And when you move back, you have to move up. So you're gonna move this way, and then you're gonna move this way, basically. So now you're here. So how many ways can you get up to here? You have one way here and one way here, so you have 2 ways. So from this point, you have 2 ways. Okay? Now we need to find out this way. So you have one way here. Now you only have one way here, as I said before for this one. So you have one way here, and then you move back, and then you move back up. And now you're right here, basically. And now how many ways can you go from here to there? So you have one way here, so there's 2. There's also only one way here, so there's 3. So for that one is 3. Okay. This one's 3. Now X here. Now, how many ways get there? There's only one, and then you have to move here, and then move back, then you have to move back up. And now you're right here, so you have one way here to get 2 here, 1 here. That's 3 here, 1 way, 4 here. So that point right there is 4. Now you have x here. So if you go here and you move back here, move up, and now you're right here. So you have one way here is 2, one way here, that's 3, one way here, that's 4, and one way here, 5. So we have 5 ways to get to B. Basically, you're just adding. So this point here plus this point is 2. You have another one here plus this point here is 3. So that's basically how I'm doing it. And this one was 5. And now we had to go with this point. So how many ways can we get up here? Basically, if we could either use this row and go up, or we could go up and use this row and go up. But we can't go to the 3rd level, basically. So how many ways get here? You got one way, one here, so that's 2. One here is 3. 1 and 3, that's 4. 1 and 4, and that's 5. So there's 5 ways to get here, and then you go back up, go this way, and then go up. And there's only one way you could go. So this one, 5 and one way makes a total of 5. Because 5 times 1. So this one is 5. Okay, now this way. So there is, oh yeah, this one was 2, this one was 3, this one's 4. So there's only 4 ways to go up here to this point, and you go here and you go here. So you only have one way here. So technically this one only has 4 ways. Now this way. If this there's 3 ways, as I said before, to go up here. Now you have to go back one and go back up, and this is the only way you could go through, as said for the 5 and the 4. So now you have to just go 3. And this one will probably be 2. This is 2, you go back, go up, and this is the only way we should go through. So this one is 2. So we have a 5, 4, 3, 2, and a 5, 4, 3, 2. So that's up to 5, 10, and 14, plus the 5, 10, and 14, and 5, 10, 14. That adds up to a 28 for a number 15, which is not right. Okay, let me check this again. Because A, 1 here, only 1 here, then you move back, then move up 1, single left, 1, 2. Yeah, there's 2 here, there's 3, so there's 1 here. Have to move back, then you have to move up, and then you have 1, 2, 3. Wait. Yeah, 3. And then this is a 4 here, and then you move back, move up 1. Then basically you have 1, 2, 3, 4. Yep. And then you have 5, move here, move back 1, move up. Now you have 1, 2, 3, 4, and 5. One's 5. Now we could go through this way, which gets us 1. A is 1 up here. So how many ways can you get? There's 1, 1's 2. You have 1, 2, 3, 4, and 5. Yeah, you have 5 ways to get up to here. And then you have 5 ways here. You have to go down 1, and then you have to go up. So you have only 5. And this 1, 1, 1, 2, 3. Yeah, 1, 2, 3, 4. And then that 4 goes up, goes back, and then goes back up, and then 1. Yeah, 4. Am I adding this wrong? 5 plus this is 9. That's 12, and that's 14. And then this is 2, 3, 4, 5. So that's also 14. And that adds up to 28. The answer is 28. I need to check that. It might be wrong for number 15 because 15's answer is 25. So I'll check that later. Maybe I'll put that in the comment section. Descriptions. Number 16, C00, U04, B34, and 30 are vertices of a rectangle. So 00, 404, so right here, and then basically 30 and 34, basically making this line rectangle. Points W and N lines on. Wait, let's label this C, U, B, and S. So W lines on CU, so right here, and BS right here. So W and N. Respectively, and W and N divides a triangle into regions with areas of 2 and 1, right? So it's like 2x to x, or it's 2x to x or x to 2x. So if M is a slope, right, of this line, or it actually could be diagonal, find all possible values of M. So since if you're moving it to 2x here and it's parallel to UB and CU, and it's x here or 2x, or x here and 2x here and 2x here, or 2x here and x here, it's just gotta be 0, so we don't need to calculate those. We just need to calculate when it's kind of like this, and that makes 2x to x, right? Or we need to calculate like down this, and that makes 2x to x, or x to 2x. So there's a little bit more combinations we need to look for. Okay. This is actually kind of difficult geometry-ish. Just kind of tedious. And now we have this angle, so it's 4 to 3. Now we just need to make a 2. It's a 2 to 1. So the area of this is already 12, right? So if this is 12, then basically 2 to 1 ratio means that it has to be divided by 3. That's 4. So it has to be 8 to 4, right? So this area 8 to 4. And let's kind of draw this box out. So we have a 4 by 3. So we have 8 by 4. So let's say the top part is 8 and the bottom part is 4. So it has to be through this point. Let's see like what's the least amount through this point, basically. So this is 8 and that's 4, basically. So this is 3. So this one has to be 4 over 3. It has to be, which is 1 and 1/3. Negative 1 and 1/3, which is possible. Which is 4 over 3, which is possible because it's to be less than 4. So that makes sense. This could be 4. So the slope 1 could be negative 4 over 3, right? And then let's say you want an area of 8 on the bottom. Okay, let's draw another picture. Sorry, the first picture looks something like this. This is a negative slope, and this is 4 over 3, and that's 4. This is 3. And this entire thing is 4. So it's less than 4, so it's good. So this will make an area 4, and that makes an area 8. This is area 12 overall. And it's through this point. Now we need to find, basically, if it's an area of, this is 8 and this is 4, right? So if this is 3, that means this has to be 8 over 3, which is 2 and 2/3, which works because it's less than 4. So this one is good too. So that's negative 8 over 3. So that covers that kind of graph. And delete this. And now instead of a negative slope, let's say we have a positive slope. So draw the box again. You usually have to look for all the possible boxes that you could draw. And let's say you go through this point and you make a line right here, and this is 8 and 4. Since this is 3, right? This is 4 over 3. And And that means this one has to also be so this is just 4/3 for this one, which is possible because that's 4. So it kind of just seems like a negative one, but now we're like flipped over. So now you could also over here put 4/3 and 8/3. Because I'm guessing like what's the least possible. So based on that, it's kind of like a testing thing. So now we need to think about like find all possible values of m. It kind of seems like there's a range of numbers that work. So now we just need to look. So I need to draw this out. So we have a box, right? And this is a 3, and this is a 4-ish. So now we could like somehow draw like a slope. It's like what's the biggest slope possible that we could use to make a thing that kind of like works. So what's the biggest slope? But it has to be on this line. So if this is 3, right, and we want this to be maximum, let's say this is 8, right? 8 here. So this one has to be 8/3. Oh, sorry, I've been calculating it wrong the entire time. It's 8/3 times 2. So if this has to be area 8, right? So length times width divided by 2 has to equal 8. So that's B4. Now, so that has to be 8. That's 16/3. So the top part has to be 16/3, which would simplify to 5 and 1/4. So that doesn't work. The slope would not work because this is like 5 and 1/3, which is bigger than 4. So what this line would do is that you have to the line would look like something like this, which goes through here. But yeah, the line has to be this line, so it doesn't work. So you can't be on this point. So if this is 8, right? Then basically, if you check, you basically need to change the x now. So now instead of being here, it has to be like somewhere around here. So now we just have to something like this. Okay. So now we just need to calculate this side because this is the side that's had the triangle. So this one is 3, and we need this to be area 4. So if this is 4, right? Then that's 8/3 right here. Does it work? That's 2 and 2/3. Yep. So that works. So this, if this is 8 and 1/3 going up, and this is 3 to the side, that means rise over run, which is 8/3, divided by 3 is just 8/9. So the highest possible slope is 8/9. That's the highest possible slope. Okay, so highest is 8/9, and now we just need to draw the next one. So let's look for the lowest possible, which is a negative. So think like this. So the lowest would be like if this was 8, right, and this is 3, and this is 4 here. So the area of this is like it has to be something like this, right? So it has to go through like this vertex and goes back down. So is that possible? This is 4, right? So I need this to be an 8. So this has to be 4. So 4 times 4, 16 divided by 2 is 8. But it doesn't work because this 4 is greater than 3. So it'll look wrong. So it'll look like something like through the vertex and it goes through here. And then you have to get that extra area, which doesn't work. So you have to move the slope down and then basically go through here, right? So you want to get like the most negative slope possible. So it's like here. So that's, and then you want to like move that slope basically away. So it has to be like something like this. And that will get that 8. So now we need to think about how that one works. So, this negative slope here. So yeah, actually need to move this up now. So you can get that 8 on the bottom. So that would be 4 here, right? So you need a, so we need to calculate this area. If this is 8, then this is 4. Then we need to get the 4 here. So since this is 3, you already have 4 here. So you want this area to be 2. So this has to be 2 times 4 is 8, divided by 2 is 4. So this area is 4. So if this is 2, that means, actually, sorry, this side it was 3. So you want this to be 4, so this would be 4 over 3. Actually, 8 over 3. So then 8 over 3 times 3 is 8, divided by 2 is 4, so this area is 4. Okay, so that's good. So that's 4, minus, and this is 3 over 4. So the change of y over change in x, so the change of y is negative 8 over 3, and change in x is 3. So this is negative 8 over 9. So all the possible slopes has to be between those two numbers, basically, now. So you have negative 8 over 9, which is the lowest, and 8 over 9 is the positive. So all those possible numbers between it works. So let's be less than or equal to m, and less than or equal to. So this is the solution set. Negative 8 over 9 is less than or equal to m, is less than or equal to 8 over 9. So to solve this question, basically kind of like test some points to see how this works, and kind of just like get a general gist of how it works. And you find, so basically from testing, you find that there's a general inequality that works with it, and then you use that idea and start getting the extremes, the smallest and the biggest. And then number 17. In the diagram below, all corners are right triangles, and the perimeter is numerically equal to the area of the circle. Find the perimeter of the find the perimeter. Okay, so let's draw this again. Put it here. Actually, the intercept that was the same size. Okay, I'm just gonna expand this a little bit more. So it looks like this. Okay, so you have a 10, a 9, a 6, and a 3, and a 1. Since this side and this side plus this side is basically 6, then this side right here is just basically 2, right? So let's just cut this off already. It will be easier. So cut this off. And this is 9, and this is 10. So subtracting that, you'll get 1 here. So if you cut off right here, this is 1. And we just need to look for this side length. We'll call this x. And this entire thing is basically 6. So if this is x, right, then we could say this entire length over here will technically just be 10 minus x. No, 9 minus x. So that would be 9 minus x. And they said the area is equal to its perimeter. So let's start finding out the area first. So we have 6 times 9 minus x to get this bottom area, basically. So that would be 9, 18, 27, 54. 54 minus 6x. 54 minus 6x. And that's for this area. Now we need to get this area, which is x plus 1 times 3. So that's 3x plus 3 for that area. And now we, for that area, now you just need to find this area, which is just x times 1. So it's just x. So overall, that's just 4x. So minus 2x. So that's 57 minus 2x as the area. Okay. We have that. 57 minus 2x. That's 57 minus 2x as the area. And now we just need to find the basically the perimeter now. So we have 10 plus that 6 right here, plus the 9, plus the 1, plus x. Since this was 2, as I said before, it's plus 2, plus x plus 1, right? Because it's x plus 1, and then plus 3. So that's 10, that's 16, that's 25, that's 26, that's 28, that's 29, and that's 32, and that's 32 and 2x. Right? And they're equal to each other. So now we just need to set them as a equation and get x. So we have add 2x to both sides, so you get like 4x. So let's say this is equal to this and put this on the right. So you add 2x here, and then 57 minus 32 is 25. So you get a y, x is equal to 25 over 4. So now we get that, and now you just plug it back into for 32 plus 2x, which is the parameter. So 25 divided by 4 times 2 is just 25 divided by 2, which is equal to 12.5. So 12.5 plus 32, you get 44.5. So that's your answer. 44.5 as the parameter. Question 18. 9 squares with the side lengths 1, 4, 7, 8, 9, 10, 14, 15, and 18 can be arranged to form a rectangle. Determine the dimension of this rectangle. So since it's a rectangle is made by these squares, that means the sum of the squares, of the areas of the squares, has to make up to that rectangle. So let's just have that. So we have 1, 16, 49, 64, 81, 100, 196, 15 squared, which is 225, and 324. I'm just going to use a calculator to add up to this. I know you can't, but since we're just going to be reviewing, it should be fine. So when you guys doing this contest by with no calculator, you're going to have to do this by hand. So 1 plus 16 plus 49 plus 64 plus 81 plus 100. Oh, plus 196 plus 225 plus 324. It's 1056. Sorry. So we have 1056. If we have to since it's length times width, right? It has to be two numbers, so it's in pairs. So it could be like 1 times 1056. 2 is 512. I mean 528. Divided by 3 is 352. 4 is 264. 5 doesn't work. 6 is 700, 176. 7 divided by 1056 divided by 7 doesn't work. It's not divisible by 7. 8 is 132. 9 doesn't work. 10 doesn't work. 11 works. I remember 11 is 96. 12 is 88. 13 doesn't work. 14 doesn't work. 15 doesn't work. 16 works. 16 is 66. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we have 9 of them. So there's 3 more. 17 doesn't work. 18. Nope. 19 doesn't work. 20 doesn't work. 21. 22 I think works. 22. 23 doesn't work. 24 maybe. Yeah, 24. And 44. And I think 32 is the last one. And 32 and 33. See, based on our number, since there is a 18 length triangle, that means every single the length and the width has to be greater than or equal to 18. So this, and this is not possible. Because it wouldn't make sense at all, you know? Because it just doesn't work. Because these side lengths are less than 18. Okay, so now you have these 3 triangles. So now what can we do about them? Since we know that it's like the length and width, right? And sometimes the triangles could be overlapping, then basically since we know one is 18, actually, since they're overlapping, something like this, right? Then basically we just need to know that the side lengths added together cannot basically exceed these side lengths, you know? So let's see if that works. So we have 22 and 48. That's 70. So 1 plus 4 plus 7 plus 8 plus 9 plus 10 plus 14 plus 15 plus 18. That's 186. Okay, they're all lower than that, so that works. Um, let's see which one. So it's a 18 and a because I'm guessing since we have these three numbers, because these are the only ones left with these three possible. And how do we find out which one doesn't work? To form a rectangle, 32 and 33. Let's just try with 32 and 33 because usually when the numbers are really close to each other, like 32 and 33, usually that's the possible answer. So let's say we have a rectangle. Let's say the 18 is part of the 32. So right here, let's say right here is 18. So I need a 14 somewhere. So um, let's say we have a 14 right here, right? We have a 14 by 14. So this is 14, this is 4. So I need to kind of get rid of those. So if I put a 4 by 4 here, maybe, right? That's a 4 by 4. So this is 4, so this has to be a 10. Okay, so we have a 10 by 10. So we have the 18's gone, the 14's gone, the 10 is gone, and the 4 is gone. So maybe we could put a 15 here or something. We have a 15 by 15. Because I'm trying to get rid of all the bigger numbers. So we already had the 10's gone. So that's 15 here is 33. So sorry. This is gonna, it's not gonna look like a square, but I'm just trying to get the dimensions right. So this is 15, 15, right? So that gets away the 15, and now we only have 9, 8, 7, and 1. So let's put like the 9 right here, right? So that's a 3 plus that 4. Oh, so it's a little bit bigger. Oh, we don't care about the general size. It's just, you just need to get that as 9 times 9. So it's a 9 here. Basically, what this is 24. So we know it's 32, so I need an 8. So let's put an 8 here. The Sorry, right here, something like that. 8, 8, 8. So that's 17. That's 32. And we have a 9, 8. We have a 7 and a 1 left over. So since this is a 9, this is a 10 and a 4. Wait, this is a 14. This is a 10. That's 24. And that's 33. Oh, so technically, this 9 covers everything right here. So this is a 9 by 9. Sorry, the diagram is bad. Uh, so what's that? 24? What was that number? 24. That makes, wait, that's 32. So 24, that's 8. So this is an 8 by 8. Right? Yeah, so yeah, this is an 8 by 8. So we have a 10 here, a 4 here. So that's 22, and that's 32. And yeah, we have a 1 by 1. So yeah, a 32 and 33 can make a rectangle. So that's the answer, 32 and 33. Good luck. It's just kind of like trial and error, I guess. You could test the other ones first, but I wouldn't recommend it. Since you already got one, then you're fine. So that's the dimensions of the triangle. That's the answer, 32 by 33. Okay. So this question is more about trial and error, and you kind of think about it, and you have to take away all the possibilities. Number 19. A square dartboard below has the nested squares with side lengths 1, 3, and 5. Okay, so the inside is 1, the outside, the middle one is 3, and the outside is 5. A dart scores 1 point in the outer band, so it's the bigger one right here. 3 points in the middle, and 5 points in the center. Two dark strikes the board randomly. Determine the probability that the score is at least 5. So, if there is at least 5. So it has to, since you can only score a 1 and a 3 and a 5, the only probability for 2 of them is either 1, 1, which is 2, 1, 4, 1 and 3 is 4, 1 and 5, which is 6. So that's 1, 1, 1, 3, 1, 5. Or or it could be the vice versa, but I'm not gonna work with those. So 1, 1, 1, 3, 1, 5. It could be 3, 1, but okay, actually I'm just gonna work with it. Yeah, 3, 1 is 4, 3, 3 is 6, and 5, 5 is, 3, 5 is 8. And you can have 5, 1, which is equal to 6, 5, 3, which is 8, and 5, 5, which is 25. So the ones that are at least 5, this is gone, this is gone, and this is gone. So it's either 1, 5, 3, 3, 3, 5, 5, 1, 5, 3, and 5, 5. So we just need to calculate the area of each of the things. So since it's 1, 3, and 5, the 1 by 1 is just... Since the outside, the entire thing is 5, it's just over 25. So the inside is 1, so it'll be 1 over 25. The middle one is 3, so that's 9. 9 out of 25. But subtract that 1, so it's 8 out of 25. And the outside is 5, which is just 25 out of 25, minus the 9, basically. So that gets a 16 out of 25. So those are the 3 areas: 1 out of 25, 8 out of 25, and 16 out of 25, which is the 1 point. Which this is the 1 point, this is the 2 point, and this is the... this is the 1 point, this is the 3 point, and that's the 5 point. So 1 and 5 is... we're only gonna focus on numerator because everything's gonna be out of 25 squared. So 16 over 25 times 1 over 25 is just 16. Oh, it's 625, but let's just say 16 first. So we have a 16 plus a 3 and a 3, that's 64, so 8 times 8. 3 and 5, which is 8 times 1, which is 8. 5 and 1, so that's another 16. 5 and 3, which is 5 and 3, which is another 8. And 5 and 5, which is just 1. So adding that together, that is 32, that's 40, so that's 104, so that's 105, so that's 123 out of 625. So that's your... Oh, sorry, I added that wrong. 113 out of... let me rewrite that, that looks terrible. 113 out of 625, right? 32, that's 40, 104, 112, 113, yeah. 113 625. That's your probability. Number 19. Number 20. In the figure below, the radii of the two small circles are 2 and 1. The path from A to 0 is traced moving clockwise and inwards without retracing, okay? So find the sum of all possible paths. So let's draw this out. We have two circles. So it's either clockwise, so it goes around this way, or you could go back down. So technically there's only like 4 points to go through here. You could always go here, 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 or here. So actually 5, since you actually start going from here, or you could go loop around and go back here. So let's say you actually start already. So you go here, you actually have 1, 2, 3, 4, and 5 ways, because you just go down and then go here and then go down, go here and go down, go here, go down, and go here and go down. So basically, you have 5 ways to do that, but each of them has to... Since you're only going from here to here, this is radius 1, so it's just already 1. And there's 5 ways to do those, so it's 5 plus... Because there's 5 methods, because if you go here, down already, then you have this way to go back down, or you could loop here and then go down this way, so that's another one. So by counting that, you have 1, 2, 3, 4, and then 5. So this is radius 1 and radius 2, so that's just length 1, but you could go through it 5 times for those 5 combinations, so it's 5. And then you go through this, which is just the the circumference is 2 pi. So this is pi times diameter. So it's 2 pi. So this is pi over 2. So each of them, so a quarter is pi over 2. So you could go pi over 2 and then go 1. Or you could do 2 pi and then go 1. And then go 3 pi and go 1. Or you could go 4 pi and go 1. Or you could just go 1. So so it's basically you could go every 5 more units to go inside, because it's the 1 here, 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 or you could loop around and then go back here. So that's 5 plus 5 more, and you could go pi over 2, or pi, or 3 pi over 2, or 2 pi. So that's for just this one. So now if let's say you are going right here to go here, since the circumference of the circle for this one, this radius 2, so the circumference here is 4 pi. That means each one of them is pi length. So it's going pi here, and then it could go down 1, and then it could basically do the exact same process. So 1, 2, 3, 4, 1 here, then 2 here, then 3 here, then 4 here, 5 here, basically. And it could do the exact same process for this all over again. So what that would basically be showing is that, let's say, now you have a pi, right, to go this way, but now you have 5 more ways, so you have 5 pi, right? So you have 5 pi, and then, actually, wait, yeah, you go here, you go down here, so it's a pi plus 1, so 5 pi plus 5, basically, and then you could go down, and then you could repeat this entire thing, basically, again. Actually, you could repeat all this, basically, again. So it'll be, oh, sorry, and then you have to add the 5. Forgot about that. So you're repeating this, basically. So now you just have to add all this again. We'll just call this x. So we'll just call x. This entire thing is called x. Let's just call that x. So we add x. And then we do the same thing. So this is pi over here. Let's just go 2 pi. So it's, pi, 2 pi. So you go here. And then you have here. And you basically do the exact same thing again for another x. So now you have 2 pi, which go by 5 again. So it's 10 pi plus our 5 plus x. And you do there. So this is 3 pi, so that's 15 pi plus 5 plus x. And then this one goes back around, which is 4 pi times 5. Wait. Oh wait, wait. This is pi. This is 2 pi. This is 3 pi. And that's 4 pi. And 4 pi times 4 is 20. Yeah. 4 pi plus the 5 plus x. Because, 4 pi, you have 4 pi here, and then you could go down 1, and then you could do the exact same rotation right here. So you have this. So we have, let's add all the, let's get rid of not using, since we have 5x, so x, 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 we just multiply all this by 5 later. And let's focus on this one. So you have 5 plus 5 plus 5 plus 5 plus 5, that's 25. And plus the 5 here, that makes 30. Actually, wait. You go 5 here, and then you go power 2. Oh, sorry, there's no 5 here, because this is 0 pi. Oops. Cancel out this one, because there's nothing here. So that's 25. Yep. So this one is initially 25. And then you have 5x. You have 5x plus the 25, and then 5 pi plus 10 pi, so that's 15 pi plus 25. So that's 20, that's 40, that's 50 pi. Okay. So 5x, what's the value of x? That is 3 pi, that's 3 pi over 2, so that's 4 pi over 2, so that's 2 pi, that's 3 pi, that's 5 pi plus 5. So x is equal to 5 pi plus 5. And you multiply that by 5, because there's 5x of them, so you have 25 pi plus 25. And now you just add the 25 and the 50, so you got 75, 50 pi, so you get 50 pi plus the 25 pi is 75, and the 25 plus the 25 here gets 50. So the entire length you could go through possible is 75 pi plus 50. Let me write that out in a new thing, because it kind of looks bad. So 75 pi plus 50, right? So worry about the outside first, and then worry about the inside, because the inside you could it's basically just a pattern. So you could go one here, and then go around. Actually, you don't have to go around, and then you could just go here, and that go in the inner circle, and then you could go 1/4 of the circumference of the outer one, and then go inside. Or you could go half of the circumference and then go inside. 3/4 of the circumference and go inside. A fourth of the circumference, so you go the entire loop and then go inside. And then inside you could just do a fourth, a fourth, a half, a 3/4, or 1/4 for every single one of those combinations. So calculating all that, you get 75 pi plus 5, which is the method I used. So that basically covers the CCML Geometry Contest 2 2016-2017 Division A. Thanks for watching, and I'll see you at the next math record.